Good morning, students. Today, the topic of my lecture for your subject, electronic devices and circuit, is liquid crystal diode or liquid crystal displays. It is also known as LCDs. LCD, as we have commonly heard this term in our televisions, we use LCD TVs, we have LCD screens, which are using the liquid crystals for the displaying purpose. As in case of LEDs, we were using the electroluminescence principle, in which there were the generation of electron hole pairs, which were liberating kind of energy in the form of heat and light, and that was producing the emission or the transmission of light. Now, in this case, there is a display of light. The display unit is being created over here also, but in this case, we are not using the electron hole pairs. But instead of generation of electron hole pairs, we are using the liquid crystals. We are using liquid crystals in this case so that we can have the display in the form of crystals. Small electrolyte crystals are being used, which are helpful in the display formation of your LCD. So let's start with the introduction of LCD or the liquid crystal diode. Intermediary substance between a liquid and a solid state of matter. Example, a soapy water. So liquid crystal diode is basically comprising of a intermediary substance that is not a solid, or it is not a liquid. Basically, it's not a basically liquid. It's not that free flowing like a water, but it is like a soapy water or a soapy liquid, a bit thick, and not that like a solid, but like a semi-solid or electrolyte, kind of electrolyte. So that is a kind of substance which is being used in case of your liquid crystal diodes. Light passes through the liquid crystal, changes when it is stimulated by an electrical charge. So in case of LCDs, we are having the light passage that passes through liquid crystal changes when it is stimulated by an electrical charge. So in case of liquid crystal diodes, what actually is happening is we are having the passage of light through liquid crystals, which changes, the shape of these crystals changes when it is stimulated by an electrical charge. The electrical passage of electrical charge, or when the electricity or the biasing is being applied to this liquid crystal diode or this liquid crystals, then what happens is the light passes through these liquid crystals. It changes and it emits the formation of light, or display is formed at the output of your LCDs. This is a pattern of your various LCD screens. Like we have a different colors. This is a pattern how the light is being transferred. This is the molecules of light or the liquid crystals which are being used. And find this is a pattern of light formation actually, which is seen in case of LCDs. This is the background structure. Then the LCDs is a flat panel display that uses the light modulating properties of liquid crystals. It is a flat panel kind of display that uses the light properties. Properties of light are being used over here. Now, what does the modulating word mean? Modulating word means changing, by which we can change, modulate or change, bring a change, optimize, modulate. It means changes. So a liquid crystal display is a flat panel display that uses the light modulating properties of a liquid crystal. It uses the properties of light which are actually modulating. You can change the light intensity, you can change the properties of light by using the liquid crystals. Now this is what is actually happening in your liquid crystal diodes. The liquid crystals do not emit light directly. They do not emit the light directly. They are basically used, we need another light source. This is one of the biggest disadvantage also. In case of our LCDs, we don't have their own light source. We require an external light source for the emission of light. So these liquid crystals are actually not responsible for the emission of light. These are just used for transference of light through them. This is the only purpose of these liquid crystals. Actually, we need an external source for the emission of light. It consists of an array of tiny segments called pixels that can be manipulated to present information. We have an array of tiny, array means a fashion, a particular fashion of particles or tiny segments which are called as pixels. Pixels are the smallest unit of light. Like we have a kind of a picture whenever we display any picture, we have its pixel quality. Whenever we click a picture from a camera, we actually see the pixel quality or the amount of pixels which a camera is having. If higher the number of pixels, the higher the quality of that camera is, and clarity of picture increases. The quality of picture increases with the higher amount of pixels in it. So pixels are actually the content of a photo. It consists of an array of tiny segments called the pixels that can be manipulated to present the information. So we can actually manipulate, or we can change, or we can bring a modulation in your crystal structures or the tiny segments of those crystal structures, which are called as the pixels, and we can convey our information, or we can present the information by using those tiny segments. Now, using polarization of lights to display objects, common wristwatch, and a pocket calculator to an advanced VGA videographic array computer screen. We use a polarization of light. We actually, when the external light falls upon that liquid crystals, then what actually is happening is the light get polarized. It get polarized to various angles, 90, 60, 75, 45, and those polarized angles of light are actually displayed at the output section. So we get a complete picture or polarized picture at the output section by using the this liquid crystal diode. Now this liquid crystal diode is basically of two types. One is your passive matrix LCDs and one is your active matrix LCDs. So basically these are of two types, passive matrix LCD and active matrix LCD. Now let's see how this goes on. Passive matrix LCD, it allows the high resolution. The resolution quality of this passive matrix LCD is very high. It is usually limited to about 50 rows. It is usually limited to about 50 rows, which is a kind of a pattern which is used for the display of this passive matrix LCD. Each subpixel is not individually controlled by an isolated thin film transistor, that is TFT. In this case, each subpixel is not individually controlled by any film. It is being massively controlled by the complete section of that display. Less used in laptops and TV. It is basically not used in laptops and TV. It is used in thin film transistors, TFTs, basically. Like we have the computer screens, which are TFTs. Then the active matrix LCDs. It uses a very high resolution, and it isn't limited to about 50 rows. It can be extended to about 100 rows also. It is not limited to only 50 rows. Each subpixel is individually controlled by an isolated thin film transistor, that is your TFT. Each subpixel is individually controlled by the TFT screens, more used in laptops and TV. It is mostly used in laptops and TV because the resolution quality is very high, and it is not limited only to 50 rows for a pattern designation. It can be extended to as much high pattern, designing as much as possible. So LCD display technology has certain enhancements. It has better color through connected CCFs and LEDs. It has improved black levels compensating films. It has higher contrast, that is a pulsed backlights. It has a wider viewing angle, that is the compensating films, the high resolution, improved twist times, liquid crystal twist times. So they have a better, in the technology we are coming day by day, there are certain enhancements in technologies. We are getting a very good black levels, means black and white picture. When we talk about black and white pictures, we are having a very dark backgrounds of black now. So higher contrast, pulsed backlights, the wider viewing angles, high resolution is there, improved liquid crystal twist times are there. So what are the various advantages of this LCD now? When we talk about the various advantages of LCD, what are the various advantages of LCD? It is very compact and light. It's very compact and light. It has low power consumption. It has very little heat emitted during operation due to low power consumption. It is very compact in size, first of all, and very light in use. That is the best. It is easily portable also. It consumes very low power. Now it is the main advantage as compared to LED. In case of your LEDs, they consume a higher power, but LCDs consume very low power as compared to the LED. Very little heat emitted during operation due to low power consumption. If they emit a very little amount of heat during the operation due to the low power consumption of those particles. No geometric distortion. There is no geometric distortion in case of your LCDs. It is very thin compared to CRT monitor. When we compare it with the CRT monitor, it is very thin, which allows the monitor to be placed farther back, from the user, reducing the close focusing related eye strain. It is very thin as compared to CRT monitors. So it can be made in almost any size or shape. Any size or shape can be maintained by using the LCDs. No theoretical resolution limit is there. There is no theoretical resolution limit in case of LCDs. It can be made to large sizes, come more than 24 inches, likely and relatively inexpensively. It can be used in a very large sizes. Basically, they are used for very large size LCDs, which is not appropriate in case of LEDs. So in case of LCDs, they are capable of being operational at a large sizes also. And they have very good resolution limit. They have small size, compact, lightweight, low power consumption, very less amount of heat emission during the operation, which is very high in case of LEDs. So these are the various advantages of LCD which make it better as compared to your LEDs. Okay. So let's move further with its comparison. Now this is the most important part. Now, what is the basic comparison between LED and LCD? If you want to choose what is LED and what is LCD and what are the various features of comparative features of LED and LCD that we're going to see in this very slide. Now, in case of LED, power consumption is less and it is more in case of LCD. Faster response rate time, the slower response rate time in case of LCD. Sizes available are 17 inches and 70 inches. Size available are 15 inches and 65 inches. So color accuracy is less, color accuracy is more. Cannot be extremely slim, it can be extremely slim also. So it is the basically the various features which make it comparable with from LED and LCD, as they are with respect to size, color, their features, their consumption of power, the response time. This all make it comparable with each other. Applications. The way it is easily applicable that we're going to see over here now. We have a thin film transistor TFTs, which are basic application of this LCDs. We have the alphanumeric displays where we need to have the alphanumeric display means where we need to display the alphabets plus the numerics. Numerics means 1, 2, 3 numbers from 0 to 9. We can display the numbers as well as alphabet simultaneously by using what? By using the LCDs. We are using the backlighting systems. It are using as a backlighting system as we need to enlight some portion of an area. We can use it. We can use the LCDs as a backlighting area for brighter displays. It can be used for brighter displays, very bright displays where we need to display the fluorescent colors, and we need to have the alphanumeric brighter displays at the output section. There we can use this kind of LCDs. So these are the various applications where they are applicable in today's world. So that is all for this presentation. If you find any doubt in this, you can ask me at your email ID, which is cited below.